with you. If you say hi, we'll hide. Because my love for you will break my heart in two. If you should fall into my arms and tremble like a playing on the radio. Let's sway. You could look into my eyes. Let's sway under the moonlight, the serious moonlight. Let's dance.
Passionate with miles away, basic
In a western town in a dead end world, the eastern boys and the western girls, western girls, western girls. Too many shadows, whispering voices, faces on posters, too many choices. If, when, why, what, how much have you got? Have you got it? Do you get it? If so, how often? Which do you choose? A hard or soft option? How much do you need? In a western town in a dead end world, the eastern boys and the western girls. In a western town in a dead end world, the eastern boys and western girls, western girls, western girls. You got a heart of glass or a heart of stone? Just you wait till I take you home. We've got no future, we've got no past. Here today, built to last. In every city and every station, from Lake Geneva to the Finland station. How far have you been? In a western town, a dead end world, the eastern boys and western girls. In a western town, in a dead end world, the eastern boys and western girls, western girls, western girls, western girls. Babe, I love you so, and I want you to know that I'm gonna miss your love the minute you walk out that door. Please don't go, don't go, don't go away. Please don't go, don't go. I'm begging you to stay. Babe, in my lifetime, I've had one dream come true. I was blessed to be loved by someone as wonderful as you.
Добрый день, уважаемые коллеги.
Dear colleagues, good afternoon. I think we should begin since most of the audience is online. Today we'll be speaking about quantum computing, and as I know, it's the first quantum session at Expo 2020 in Dubai, UAE. And I believe we'll be having a very interesting discussion today. And to be precise, we'll be speaking about quantum computing as the answer to global challenges. In addition to learning about what quantum challenges quantum computing will help solve us, we will also learn about the challenges that the creation of quantum computing has itself. But before we proceed, let me introduce the speakers. Ekaterina Solntseva, who is the Chief Digital Officer at Rosatom, Tomasa Kalarka, who is the author of Quantum Flagship, one of the first international quantum computing programs. First it was $1 billion, now it's $7 billion. So it is the person who has started this program in Europe, and Tomasa is also heading the Quantum Center in Jülich. Daniel Loss, who is the professor of the University of Basel, and he was awarded with King Faisal Award, a very respected professor. Online, I welcome Christopher Monroe, who is the co-founder of IonQ, the first unicorn startup in 2021, and hopefully Christopher will share how it was possible to create this company. Christopher is also a professor and the head of the Quantum Center at Duke University. Good afternoon, Chris. We also have Jose Ignacio Latorre, who is the leader of the National Quantum Program at the UAE. It will be very interesting to listen to his insights because I personally didn't know that the UAE has the quantum program. In Dubai, we see that here we have everything of the highest things, the most expensive things, so maybe their quantum program will also be the best one. We'll see. And we also have Maxim Parshin, who is the Deputy Minister for Digital Development, Communications and Mass Media of the Russian Federation. And most probably I will begin with Maxim, who's responsible for quantum computing in the Russian Federation. Maxim, you have the floor. Dear colleagues, dear friends, I'm happy to welcome you at Expo 2020. It's an important panel discussion on quantum computing. Thank you for joining us. And the Ministry of the Digital Development considers quantum computing one of the priority directions in its work. And the leading company here, of course, or state corporation is Rosatom. The government of Russia allocates quite a lot of resources into the creation of quantum computing. And we understand that without quantum computing, in the near future, it will not be possible to be or remain a technological leader. Quantum computer will allow us to solve tasks that are not possible to solve for traditional computers. So we can confidently say that it's impossible to become a technological leader without quantum computing. Of course, we need new technologies, quantum computing devices of thousands qubits will allow us to solve new tasks. And currently Rosatom is working with 4 directions, superconductors, phantom chip, and others. And we have certain results here. None of the directions is a leader right now. We have to be working on them in parallel at the same time. And hopefully in the nearest future, we will single out just one or a couple of most promising directions in which we will keep developing. As per our roadmap that is approved by the Digital Technologies Committee in 2025, we will create a prototype of a quantum computer that will allow us to tackle real applied tasks. So currently Rosatom and all of the cooperation related to quantum computing material base, and in the nearest future we will move to actually solving the real applied problems or tasks. And I would like to highlight that we are happy to be part of this profile specialized world community dealing with quantum computing. And hopefully in the nearest future we'll be solving tasks that we have today. Dear colleagues, thank you for the opportunity to be speaking at this important event. Maxim, thank you so much for your introduction. You know, we are at Expo 2020 in the UAE, and it's an example of how the world can collaborate. Here we have about 200 pavilions, so 200 countries have assembled here in one place, and I do not see any conflicts here. People are happy to attend all of the pavilions, so this is an example of international cooperation. I would like to address Daniel Loss. If we move to quantum computing, you are from CERN, and it's a mega collaboration, thousands of people working towards this global goal, and you have had certain results. Is it a crazy idea, or is it not crazy that sooner or later we have to have such centers within the quantum program that unites the efforts of scientists from various countries? Would such a project have sense, and if it would, does Switzerland see itself as the center of such a project?
Is it okay? You can hear me? Yeah, thank you very much, Ruslan, for this very interesting question. I'm not here in an official function to speak for Switzerland, I should say that, and I'm not working at CERN myself. Of course, you know, CERN is a part of Switzerland, and I understand your question. I think it's a very interesting question. Will it be in the same form as CERN, that we could have a development like that? I would say this was a question. I've been in the field since more than 20 years, and that was a question which was discussed actually very early on, if this is possible. And some people said yes, some people are a little bit skeptical. And I think in the meantime, we see now developments which go to a certain extent in that direction. Because you know, you need a certain size, you need a certain critical mass, and they are now probably a little bit more individual in countries where such centers are being built up. Now, you said, you know, many people from different countries are participating in CERN, and I think this is also true for the centers which we see now coming up in the world. You know, Germany has very much large centers. In Switzerland, we have a national program on quantum computing. This involves then scientists from basically all universities in Switzerland, and they are all coming from all over the globe. So the science itself, of course, is very international, and we are very open to collaborations in this field. I think maybe in the now the development which we see is that also industry gets interested, and there is also potential for money, and then it gets probably less likely that we will have something like CERN, because there's also the kind of promise of really making money in the field. So maybe I answer your question to this direction. I mean, Switzerland definitely would be happy, you know, if the global community would decide to have such a center to host it. But the development right now I can see is that many countries invest a lot of money in their respective countries. But still, collaboration is worldwide.
Thank you so much for your comment. And speaking more about collaboration, I would ask Tommaso Calarca to tell us about what difficulties you had with Quantum Flagship, maybe about something interesting about your program. It's a European program, and later it gave birth to some national programs, and it's interesting to see how they're all interrelated, how from a bigger program we have some individual programs, and is this program ready to go beyond Europe and collaborate with other countries? Of course, I would personally see Europe collaborating more with Russia in quantum field. And if we have some time, hopefully we will, I have another question. For the past year or two, Tommaso, you have been working actively with industry. It's collaboration not only between countries, but it's also a collaboration between scientists and industry. What interesting insights can you offer?
Which is here in my pocket. And it is a story which answers both questions. And this is something which most of you do not know that exists. And all of you have never seen in reality, even if you know that it exists. This is the first consumer commercial device based on quantum technologies of the second generation. It's a cell phone, which is a Samsung A Quantum. I'm not kidding. Inside it is a quantum random number generator, which was produced in Switzerland by the startup IDQuantique. And now, when I gave a presentation last summer at the G20 in front of all the ministers of innovation and research of the G20, when we gave the first demonstration of our European infrastructure for quantum communication, EuroQCI, I had this in my pocket, but I left it in the pocket because if I took it out, a few people would have killed me. Why? Precisely because of the reasons and the difficulties associated with Ruslan's question. Now, if you ask me, as a scientist, this is a great thing because it really shows that IP produced in Europe coming out of the European quantum programs, intellectual property patents, they get globally developed by a Korean company. So South Korea is producing this and it can reach consumers. However, we cannot be naive to the argument which the European Commission has, which is we are investing a very substantial amount of money. We also want that the value which is created is going to the benefit of European society. When I went a few years ago to ask Hartmut Neven, he is a German person, he is in Venice Beach, California, very nice place to visit, like here. So it's always pleasant to visit him, and I went there to ask him on behalf of the European Commission. Now, how can we stimulate a comparable engagement of industry in Europe on quantum as we see in the US, because Google is investing several $billion, just Google, on quantum computing. And Hartmut Neven told me, you cannot because you do not sit on a pile of cash. And I came back and I spoke to the CEO of Bosch, which by the way is the company which produces this little thing which everybody has in their pocket in this moment. And Mr. Denner told me, and I told him, can you give me a counter argument? And Mr. Denner said, no, he is right. And why is he right? Because the enormous profits of the internet revolution, the web was invented in CERN, as we know. The money is sitting in the US. So the profit margins from something which was European IP are not in Europe. So, as a scientist, I'm not in favor of protectionism. On the other hand, I must also understand our decision makers, when they say we are investing very strongly, we want at least that our societies take part in the exploitation, in the economical advantage. So this is the tension between cooperation and competition. How do we solve it? Well, I think we have currently an enormous problem with Switzerland because Switzerland kicked itself out of the European programs for research. They keep saying that they don't, it is not true. They are fixing it, they are working on fixing it, and we are very strongly, working for keeping them inside. But again, we had a similar problem with the UK, And we as scientists, we work very strongly to make sure that Europe is united even beyond the European Union. We cooperate with Russia. We have several colleagues which cooperate with China and so on. But we need a common IP platform. We need a clear regulation for standards and for protection of intellectual property. This is something which we will need in order to be able to go to the next stage of cooperation if we want to connect science and industry in the quantum domain.
Да, спасибо. Спасибо. Очень интересно.
Thank you very much. It's a very interesting comment. We will get back to some organizational questions, but now I will give the floor to Ekaterina. Ekaterina, we see that there are several quantum programs in the world, and maybe it's not a typical solution that was chosen in Russia, such as individual state corporations to create roadmaps. Obviously, everybody understands why Rosatom was chosen to work on quantum computing. But this organizational aspect is not very obvious. So what is the role of Rosatom here? Where do you stand as a company? Ruslan, thank you so much. Indeed, Russia, as it always happens, followed its unique path, I would say. If we look at the developments of quantum computing in various regions of the world, we will see that the path of the United States is a path through a major IT giants, startups, and we see how much money is being invested by state corporations. If we look at Europe and Asia, and it's an interesting combination. Here we have science, universities, and quantum centers. They are around scientific centers. In Russia, indeed, it happens so that it's not only quantum technologies, but also many other technologies were given certain curators or coordinators in the face of corporations.
At first sight, it may appear that this is not a typical situation, although in reality it's not too far from what's happening in the other countries of the globe, because in reality state corporations, well, you see, there is no expectation towards them or towards us that we would develop quantum technologies inside the state corporations themselves, that we would invest into them ourselves, that we would develop scientific centers. What they're expecting from us is to organize the cooperation inside the country and with the international community. Consequently, in our program, we have active participation from technological companies, mostly tech startups, of course. Also very active are scientific centers, beginning with the Academy of Sciences that conducts monthly meetings and roundtables and strategy sessions on quantum computing. And ending with, although I don't really like this word ending because we're not ending with anything, but still ending with the active participation of universities, not only Moscow universities, by the way, but also other universities from Russian Federation, including Nizhny Novgorod, the Far East University. As a result of all this, we set our target as coordination and bringing together the efforts of different players so that we would be able to have the relevant outcome. And at the same time, all this is done with the co-responsibility of the Ministry of Digital Development, because, let me tell the audience, it wasn't by accident that Ruslan, when he gave the floor to Maxim Parshin, Deputy Minister of Digital Development, mentioned him as the one responsible for a quantum computer appearing in the country. Right, it's not just the responsibility of Rosatom. We are sharing responsibility with the ministry, and it is with their help that we do not only focus on the roadmap for quantum computing, but also we are developing the principal model of cooperation between the regulator, the state coordinator, and the participants of the market. We are developing a model that would make it possible to ensure faster, accelerated movement towards the development of any strategic area, really. And here we all play our own roles. For instance, our role, what is Bring Together? It's not only about organizing the joint writing of the roadmap and following up on its implementation. It also includes identifying barriers that exist on our path. Quite frequently, they require the involvement of the regulator to get rid of such barriers, and the regulator must indeed cooperate with a similar, if I can put it that way, organization, so that the regulatory restrictions to be alleviated as soon as possible. First and foremost, this applies, of course, to state financing. There are strict rules for state financing, that's clear. And when in reality we need to direct the state money at the development of startups, that requires the relevant legislative activities. Right, thank you very much. Thank you, Katja. You concluded the first part by saying that the state is supposed to finance startups. And yes, indeed, I guess in Russia so far, other instruments, especially in the quantum computing area, are not that well developed. And I'd like to speak to Christopher Monroe. It is indeed a very important event that we have a startup with a capitalization of more than $1 billion in the 21st century. And Thomas also mentioned that, yes, they're sitting on a pile of money, right? It's simpler for them. In any case, it just appears so, but it is a colossal effort that Christopher's team and himself have conducted over the last few years. So Christopher, if it's not a secret, could you please share with us, how can we also develop a major project, a major startup for the industry, for the investors from the market to be prepared to give us a lot of money?
Thank you, Ruslan. It's a pleasure to be here. I wish I could have been there in person. So your question concerns the company IonQ, which was a startup I co-founded about 5 or 6 years ago with Jungsang Kim, who's a very well-known quantum engineer of a new breed. Your question is how was IonQ capitalized the way it is, and now it's a public company. I must say this happened much faster than I thought, even the formation of the company, and then of course I never anticipated, none of us did, that it would be a public company with such a large capitalization, allowing us to do our own research, for instance. I mean, we're not Google. I wouldn't say it's an infinite supply, but we're very thankful of places like Google, and of course the decades of research that led up to the particular technology we use. And I would say, in our case, what happened is we have developed a very exotic technology that is not something that you would normally think would be part of a computer. These are individual atoms in a vacuum chamber with laser beams poking on the atoms. So I think that kind of technology, I think it was too exotic for big companies, the ones that make conventional computers, but it's much higher performing. And so we made a very compelling argument that quantum computing is a revolutionary form of computing, and it will demand revolutionary technologies, not just silicon. There's no reason a quantum computer in the future will have any silicon in it. And I think this was maybe not easy for many in the field to understand. And indeed, silicon can be made quantum by certain accounts. And I would say Daniel Loss on your panel there, he was one of the first to really push the idea of using individual electron spins in a silicon matrix. But I think over the last 2 decades, we've come to realize quantum computers are not necessarily best made out of solid state materials. And so we at IonQ were one of the first commercial entities as a small startup company to start to translate this exotic technology from the laboratory to a product, to real systems. And I think that, we were a little bit ahead of the game. And this is, I'm very thankful that, of course, much of the work in the cutting edge systems in the field are coming from industry now. And there are many more small companies now that are using atoms, including, well, it's not yet a company, but in the Russian Quantum Center, for instance, at the Lebedev Institute, there's a wonderful team of researchers that are working on the same platform we are at IonQ, individual atoms. They had a major result at the end of 2021. And I think all countries from Germany to the US, this new exotic technology of individual atoms that are poked at with laser beams is starting to take hold. There's a lot of work still to be done. We can build systems, but they're still too small to create commercial value right now. But I think it's a matter of time. We'll probably talk a little later on timelines. I think it's sooner than everybody thinks. I think it's a matter of a few years before we start to see applications happen. But you asked about IonQ and it's being a public company. Indeed, we now have a big budget to be able to do things in parallel, to do research and development on future systems, and just to build our team.
Да, спасибо.
Right, thank you very much indeed. But Christopher, I cannot help myself. In the next few years, where will the technology move? We'll come back to our scientists with the same question, but there are different notions, right? You can build one big processor, right? Or you can have a series of small processors and bring them together somehow, link them somehow. I think the microphone is dying on me here. Right, if you can hear me well now. So, Christopher, where will the ions move in your project? I mean, how will your technology develop in the next few years if it's not a secret?
I'm glad you asked that question, Ruslan. I believe that any technology in quantum computing is going to have to grow in a modular fashion. In other words, it's going to have to be a network of smaller systems. It doesn't matter what the technology is. Quantum computers are a perfect example of a complex system that as you grow it, it gets more complex than you think. It almost demands that you do it in a modular way, sort of like the way we build multi-core silicon processors today. Or if you look at, one of my favorite examples of a modular complex system are airline route maps. I mean, there are hubs, it's not economically feasible to fly from any city to any other city. A quantum computer, it's not. I think it's going to be very difficult to just build a big single unit. It's going to have to be networked, and that implies that the networking medium are photons, going maybe through optical fiber, maybe waveguides, but optical photons. So we're looking for qubits, quantum systems, the transistors that can connect naturally to individual photons. This is a very natural thing for atoms and trapped ions. They are optically active, and there are other platforms as well. But this is really the architecture for a large-scale quantum computer. And I will say, without that idea of having a networked quantum computer, our company, IonQ, would never have happened 5 years ago. It was this long-term vision that our investors believed in. They knew it was long-term, and we were lucky that they were patient to be able to invest in a company that they knew would take many more than 5 years to really produce value. So I think this is more general than just atoms or ions. I think I think any large-scale quantum computer will have to be modular. And when you hear the term quantum internet, quantum communication network, and quantum computer, those are all the same thing. In the long run, they will all be the same thing.
Спасибо, Кристофер.
Thank you, Christopher. I think that for us, as the representatives of Rosatom here today at the session, the main purpose of the session has actually been accomplished. And I didn't anticipate this, I didn't say it, but it was already mentioned that there is a roadmap, right? And Katja said up until the end of 2024, but in reality, in this year, we have to prepare a draft, some sort of a vision of the roadmap up until 2030. Having listened to Christopher, I'm reconfirmed once again that we have to develop quantum internet up until 2030. So we will have to be working on connecting smaller quantum processors into something bigger that will ensure growth of productivity. So for us, it's already useful. Thank you so much, Christopher. A very good session indeed. Well, of course, this is not the end of the session. I'm just kidding. We have one more speaker, a very interesting speaker indeed, Jose Ignacio. Let me ask you, could you please tell us what is a quantum program in the United Arab Emirates? Could you please tell us about that? That's interesting.
For organizing this roundtable. Let me answer to your question with 3 different levels. The first level is national, the Emirates level. So in 2020, a new center was created, a new institution, under the name of Technology Innovation Institute, with the spirit of starting to move from an economy based on oil to an economy based on knowledge. This is really a remarkable effort that the Emirates are doing. And this TII institution was born with the spirit of detecting what are the technologies which are needed in the Emirates and that provide an opportunity for developing them. So next to TII, another center was created, which is Aspire. Aspire is a center that detects the needs for the country and the opportunities and talks to TII to develop them. And then an umbrella for all of them was created, a research council for the first time in 2020, which is the Advanced Technology Research Council, which now has these 2 legs, and in the next year we have a 3rd leg related to investments. So as you see, it's really a major effort. And within this TII, one of the lines, there were 7 centers there. One is for quantum technologies. There is another one for cryptography. There is another one for autonomous vehicles and so on. The second level of my answer is now going into the research center for quantum technologies, the Quantum Research Center. And the basic idea there was to align with what's going on all over the planet. So was selecting a number of quantum technologies that are relevant and start to create a background just to build up the capabilities in the Emirates. And 6 lines were designed. One is quantum computing, hardware. Another was quantum middleware, so all the control technology for the quantum computing. A 3rd one was quantum algorithms, so how to find solutions for the industry. Then there were quantum communication, of course, hinting at the possibility of eventually working on the quantum internet. And then quantum sensing, in particular levitation of particles. And finally, you need always basic science, so quantum physics as a basics for all of that. This is the 2nd level, how the center is organized. And then let me just add the idea of how we want to work. So the basic idea is that we follow the scientific standards of the international community. So we collaborate plenty with every one of our colleagues. By the way, we are in 1 year and a half, we have gone from 0 to 46 people. And the aim is to be around 80 in a year and a half time. The collaborations, though, are different when you write a paper and when you develop hardware. And it was not a surprise, but it happened, that there are exploitation bans. Okay? This is never mentioned, but it's a fact. 3 times we were not allowed to import equipment. So that means that the philosophy of the center is build, not buy. We are trying to build all the capabilities. Our labs are now well equipped, and clean room was made. And so we have to really be consistently sufficient, auto-sufficient. This said, there are different countries in the planet with different attitudes, and in particular, we do have 3 collaborations on the hardware side with different countries, 2 in Europe and another in Asia. So we do have collaborations, and hopefully we will have many. And I would like to finish with an idea which I think is very relevant. Everybody is focusing on quantum computing, but there is a lot to be done on the enabling technologies. So an effort is being made in not just focusing on quantum computing, but also understanding that many technologies which are providing the possibility of doing this quantum computer are necessary. And there again, we are talking now to other countries which are very open to share, let me say, the level of enabling technologies. So the spirit is that TII will be at international level. It is getting to international level in a very short time, with a very clear focus, as you see.
Спасибо большое.
Thank you very much indeed. You know, right now I would like to switch the focus. We already touched upon the technological parts, and it's clear that quantum computers have to address the challenges for humankind, and we have faced them in the last couple of years. Take COVID, for instance. This is the challenge that you can see. And the quantum computer, if we had 10 years reserved, maybe the quantum computer would have been useful now to address such challenges. But I'd like to concentrate on some other questions. What challenges do the quantum technologists need to address to arrive at a quantum computer? Or, for instance, Daniel, Christopher mentioned that you were one of the first ones to talk about the spin qubits in silicon, etc., etc. But Maxim Parshin today mentioned that there are main platforms selected in Russia, and this is not a unique story. These are the main platforms, are the leading platforms in the world: superconductors, atoms, ions, and photons. Spins, by the way, are not among them. But if we were to take 10 years ahead, what do you think? What sort of platforms will be the leading ones in 10 years' time?
Much, Ruslan, for this question. I think it has already been touched upon, as you said, by Chris Monroe, that in the field there are certain players. In the field, there are a number of very promising players, and you have mentioned them: superconducting devices, ions, and spin qubits. And I think it's very, very difficult to consider this as an equal level race. And it's almost like a marathon where you don't really know how long the marathon is. There will be a goal, and to judge from an early part of the race who actually will end up winning that race is very difficult to predict. I would also not really want to subscribe to this kind of competitive thinking that we should think of a race. It's more like also a kind of collaboration. I mean, as Chris mentioned, it's very important to build up networks, right? And there is something which is developed which can be used across the platforms. I mean, hybrid systems, they are thought of interaction between solid state and photons is something which is very basic and very important. So if that is being figured out, how to do this kind of networking in the ion case, then you can also use it in the solid state and vice versa. Now, being a little bit more, let's say, focusing on my own kind of research area, and that is in silicon. Silicon has been mentioned now a few times. And I think just in case no one knows, I I also show now an iPhone, and I think every iPhone you see here has silicon chips in there. And silicon chips, just for people who don't know, consists of transistors, the basic unit. And a silicon chip of a square centimeter has about 10 billion transistors. For a quantum computer, we would need about 1 billion qubits. And spin qubits in silicon have the size of a silicon transistor of today. This has been demonstrated in the lab and has been shown in many different labs also across the world. I mean, there are big companies working on that, like Intel. Also, IBM is working on this, and many others. And there are many, many academic labs which work on silicon. The progress compared, let's say, to superconducting qubits in terms of the number of qubits is not very large. I mean, we are talking here about 4. There is now a promise of 16 qubits, let's say, from the Delft lab. And this is about the scale where we are compared to 50 or even more, approaching 100 in other cases. On the other hand, you also have to look a little bit further ahead. I mean, there is kind of a mid-term benefit coming out, but if you want to go for the holy grail, that means really a working quantum computer, there is a part of the community which has a very strong belief in the basis of CMOS technology. CMOS technology is the most highest developed technology mankind has ever invented. I mean, the promises, you know, they have all been fulfilled on that platform. People actually didn't even think about that 50 years ago, how fast it would go and what kind of tools which we have at our hand these days. And based on that experience, one could say, well, I believe it could also be used as a base for future developments in terms of quantum technologies. Of course, you know, there's no guarantee, but I think there's a very good reason to believe in that, because it's a technology which has proven itself again and again and again. And I think the investment in that technology is almost, you know, it would be a mistake not to do it, especially also in a country like Russia. I think it's something you cannot just forego. It is required to have an international effort on that. It's very hard to imagine that one single company, one single lab will just be able to develop that. We see this now currently in the field. There's so many developments which look from the outside like little steps, but inside the field there's still basic science steps which are big, which are very, very important. And the development, let's say now in the silicon-based CMOS technology, is that we are on a flat race, and you know, we can expect at some point how this goes out. In 10 years, coming back now concretely to your question, I think it would not be serious for me if I would make a prediction on that. If I listen to Chris, and if I look, you know, how convincing he actually sells his company and how successful it has taken off, I think, you know, even Chris said he couldn't foresee that. You know, even, you know, in this business, it's very difficult to foresee such developments. But if we look back now the last 1, 2, 3 years, it's amazing. It's amazing. And I don't think anything will stop this development. And it doesn't really matter in which field. It's even stimulating. It's cross-stimulating. If someone like Chris with his company is very successful, I think it stimulates also other developments. And I'm very hopeful that in 10 years we will definitely have machines which will do something which goes beyond the classical machine. Whether we will have a fully functioning quantum computer, I would not exclude it, but I cannot promise it either. But I think, you know, as someone said, if at this point you do not invest into quantum technology, you run a bigger risk than not investing in quantum technology. Because the benefits which are promised are so big that this kind of risk comparison tells you you have to. It's almost, you know, it would be a mistake not. This is my opinion.
Спасибо большое.
Thank you very much. This actually aligns. You know, I'm reading a book now, Anti-Fragility by Nassim Taleb, and he says that predicting black swans, the improbable events, is impossible. But you can build a system in such a way that when the black swans do come, the system would be ready for them So this is aligned with what you're saying. We don't know exactly what's going to happen in 10 years, but what we do know is that we need to prepare now. We need to create the system, and we must be competitive when something actually happens in 10 years' time. I fully agree with you that without this, it wouldn't be possible to live in the future. It wouldn't be able to have a competitive economy in the future for any of the countries. And I also have faith in this. Thomas, it's difficult to ask you the same question because Thomas represents an entire program. And if Thomas is told that one of the areas is going to prevail, then people will start calling his quantum phone saying, Thomas, you're forgetting about us. People will start calling him during this session. But I think it would be interesting to hear some comments from Thomas. And in addition to that, one more question. What about the industry? What does the industry expect from you, from us, from the scientists in 10 years' time? I think that Thomas has to answer this question all the time.
So, happy to answer both questions. Well, the first one is that still, as Daniel said, it would be very unwise to stop investing in a range, to diversify the portfolio, if you wish, of investment, because just focusing on one platform, I mean, we have had surprises. For instance, neutral atoms were completely off the chart until maybe 3 years ago, and nowadays Europe's largest quantum computer, which is going to be installed into supercomputing centers as a coprocessor in Paris and in Jülich, is a neutral atom-based quantum processor, which is with 200 atoms. It's based on a technology which is also developed by a startup in the US from a very prominent former predecessor of Daniel Loss as chair of the Russian Quantum Center International Advisory Board, which is Professor Misha Lukin from Harvard University. And this is really something where we have seen this technology taking off in the last few years. So I would say nowadays we can see maybe 3-4 technologies, and surprises are still coming at a strong pace. This morning in the taxi, I was commenting with Daniel the amazing progress that we have seen from semiconductor qubits, which until a couple of weeks ago had not yet published demonstrated achievement of these very, very low-level errors which are necessary for fault-tolerant quantum computing. And now we have 3 papers in the prestigious review Nature, in which 3 different groups in Australia, in Europe, and in Japan achieve that level of fidelity. And Daniel is right. If you play the long game, at the moment, we don't have ideas how do you really scale up concretely superconducting qubits or ions to a number of millions, okay? There are ideas how you approach that problem, and Chris has mentioned the fact of connecting smaller processors with photonic channels. But really, do we have a concept which we know will function with millions of qubits? No, we don't. With semiconductor qubits, we have a concept because we can fabricate millions, but we don't know whether it will work, because at the moment they have shown that there are 2 of them which work. Okay, so it's a much smaller number, and the next generation is 16, as Daniel said. So you see, great long-term potential, but will it work? It is like a very big orchestra of millions of qubits. They have to play together in quantum coherence. Nobody knows whether it will work. Okay, ions and superconductors, and also atoms. I mean, until a short time ago, people said, no, it's not scalable, but now we see much more progress than we expected. So surprises are still coming, okay? And I can tell, yes, for each particular aspect, of what will be needed for a quantum computer, yes, this is maybe the most promising technology. But for all aspects which will be necessary to build a quantum computer, no, we do not yet have that. So that's a scientific fact. It's not a political truth in the sense that you have to make everybody happy, but it is a scientific fact. Now, what does industry want from us? Industry, very clearly, in the next several years, they want to be able to use those machines, to develop their use cases, to play with these machines as they keep growing, and to deploy the problems which are relevant for industry and to translate them to a language which can make them usable on quantum computers. So this is what we are doing with this initiative, this other European infrastructure, the European Quantum Computing and Simulation Infrastructure. The first pilot project is what I mentioned, in which we take 2 such quantum simulators and computers from the French company Pascal, and we deploy them in supercomputing centers so that we create access. 2 weeks ago, we had a big event in Paris, in which the national program in France was announced for this providing access to industry. Same thing, 1 week ago, we had a big inauguration with the European Commissioner, Minister, and so on in Jülich of the same kind of idea. We are combining this at European level. This is what industry wants. They want to be able to start playing with these machines. We are discussing, I mean, I had a meeting 3 days ago with Chris Monroe. We are discussing about possibilities of connecting also with other hardware providers. So this is the challenge. This is what industry needs now. This is what we are going to work very strongly on in the next years.
Да, спасибо.
Thank you very much. So industry does want to get their quantum toys, and probably it will make scientists develop technologies faster and faster. I'm not sure if Jose can answer my question, since the center is just being created and it's still relatively small. But anyways, my question is, does UAE wait something for you, from you as the center, or it's still too early to be speaking about this? Очень...
UAE is putting a lot of pressure. Let me add to the comments of my colleagues that it may happen that different platforms, different qubits, may be better for different tasks. So it may happen that indeed, if you want to do certain simulations, neutral atoms are fantastic. If you want to attack cryptographic protocols, then you need a universal computer, and maybe then ions and silicon and superconducting currents are fantastic. But maybe if you want to do a Monte Carlo simulation, it turns out that photons are. So it may happen that, as in the classical computing paradigm, you have CPU, multi-node machines, GPUs, multi-GPUs, and now TPUs, tensor processing units, because you address different problems with them. Then it may well happen that in quantum, a similar thing may happen, at least in the midterm. Okay, I don't know in the long term, but in the midterm, this may be. So what is our strategy? Is we are starting to work in superconducting qubits as a first platform. Yet it is extremely open to other platforms. Any other ions would be definitely welcome. It is certainly true that some platforms have a barrier, a larger barrier to create. You need the expertise is enormous, the needed expertise. So in this sense, we have to proceed in a humble and ambitious way. And as I said before, we have to team up with people in all over the planet. But definitely we are open, and we want to serve the industry as much as possible. Actually, we are finishing a cloud access system. But it should be clear also to the industry in the Emirates that we follow this philosophy of no hype. I mean, what the industry may be expecting, it's very difficult to fulfill at this moment. Okay? I think one has to keep expectations at the right level. Otherwise, there will be a dejection in the short term.
Да, спасибо. Действительно.
Thank you very much. Indeed, we see high expectations that later lead to disappointment. Despite all this, I would still like to ask Ekaterina about their expectations from their quantum program for Rosatom itself. What expectations do you have? I think I will not share anything surprising. What we expect from the quantum program is to make Rosatom competitive by using quantum computing, and we have begun work on, and the first challenge that we have is to involve businesses so that they can set up tasks for quantum computing. For the past year, we've spent quite a lot of time on conducting various training events for various groups inside Rosatom and in Russia in general. And we had quite expected seminars for students, for young people. We also had an unexpected experience when such training seminars were conducted at the Ministry of Finance. And after that, they told us, yes, we are willing to do strategic sessions with other ministries, with other financial organizations. We want to think about how the appearance of quantum computing and algorithms will impact the financial sector. So it will naturally have an impact on any structures in economics. Getting back to the tasks of Rosatom itself, we have created a list of tasks that could be solved with quantum computing, first of all. And the priority is for optimization in nuclear industry, for example. Ruslan's colleagues have created a quantum algorithm that allows us to calculate optimization of loading into containers and other tasks not related to nuclear industry, such as optimization of work related to the Northern Sea route. I hope many of you know that we are doing many things apart from nuclear energy. We also do wind energy, nuclear medicine. We are also the operator of the Northern Sea route, which is the shortest route from Europe to Asia. One problem here, it's covered with ice. So we have nuclear icebreakers. And right now, cargo flow is quite substantial on this route, so we are now also a logistics operator. And the more we have other tasks of transports, logistics, then the more the potential of optimizing this process, starting from loading ships to logistics itself. Thank you. Christopher mentioned Carl Montan-Evan, who is the head of the quantum program at Google. And this is what I was thinking. 10 years ago, when we were just looking for investments and we tried to convince various people in Russia, we told them Tomaso Kalarka was convincing many people himself, and many people told us, oh no, we don't believe in it, it will not work. Later we saw some shift inside the minds. Nobody is now speculating on whether it's a reality or not. Now everybody believes that it can work, that it will be useful. So there has been this shift in the minds thanks to the key event at Google 2 years ago when they announced their quantum supremacy, when the quantum professor could solve the problem that was not possible for any other computers. It was a meaningless problem. It was chosen for the quantum computer. It was important to see this quantum supremacy. I will start with Christopher Monroe, but everybody else can join and make your comments. So, Christopher, what is the next key event that we should expect in the world, and when do you think it will happen? The event that will create another shift in the minds in terms of technologies. Do you think there will be such an event at all? Christopher, you have the floor.
Very good question. A question of the hour, the year, the decade. I'm going to, I was pleased to hear pretty much what all the panelists have been mentioning about building systems and having, Katya mentioned all the applications where quantum can play a role that are very far removed from a typical curriculum of a quantum physicist, right? And to me, this gets to what Tommaso and also Daniel were talking about, the new components that are coming out. There's wonderful physics happening in this field. Tommaso mentioned neutral atom platforms, which are coming on very strongly right now. The one thing that we have to all keep in mind is that I think the big events in quantum computing that will come over the next 10 or 20 years probably will not be about components. It won't be about the physics of individual transistors. Just like in 1970s, the big events in computing, it was VLSI, it was CMOS. It was, as Daniel mentioned, bringing in millions to billions of transistors. It wasn't looking at an exotic semiconductor like germanium or gallium arsenide. That was research, that was component research, very valuable physics, but we're now at a stage in the field where we're beyond physics. We are starting to apply applications, real world applications to these devices. Katya mentioned a few of them. One big surprise for our company at IonQ is that we're running, even on small quantum computers, we're running several financial optimization routines with companies like Fidelity, with Goldman Sachs. And this we wouldn't have anticipated. They're learning how to, a new way of optimizing certain cost functions. It's still on a small quantum computer, but as we scale and make the system bigger, it's anticipated over the next few years that they will be able to do something they couldn't do on a classical computer. It won't take billions of qubits either. With trapped ion qubits, it might take 1,000 because error correction thresholds are so much better in this system. So again, I think we should try and, when it comes to predicting the next big win in quantum computing, it probably won't be the component level, because that will take 2 decades to develop into a real system. We have to start building these systems and look and bring applications experts from fields that are not quantum to use these systems. And Tommaso's full-time job at Jülich in Germany is a perfect example of this, where they're beyond physics now. They're building systems, they're fielding quantum computer systems of all different types. They don't care what it's made of. They just want application specialists to use these systems. So your question concerning what's next beyond the many demonstrations, including the Google, very well-known demonstration a few years ago. There are many others that fall in the same category that are very researchy, things that you could not do classically. I think the next big, in fact, a much bigger step will be doing something that's useful. Picking a problem that is actually going to make commercial value. And I think this is not, I don't think this is 10 years away. I think it's more like 5 years away.
Да, спасибо. То есть это...
Thank you so much. So we will have this useful quantum supremacy in terms of Chris Monroe's view. Maybe, Tommaso, you will make some comments here. I would like to ask actually all the speakers to make some comments on what the world can expect.
This is what we refer to with quantum advantage, which means quantum supremacy, namely the possibility for a quantum computer to compute something that the biggest classical supercomputer cannot do, but for a problem of practical, real relevance for creating value, for industry, for any application. So this quantum advantage is not necessarily going to come in just one major spike, but it is going to be, you know, crossing this threshold for a range of many problems, as Chris was mentioning. So this is what we need. It is true. This is what will come. This is what we expect. On a shorter time scale than 10 years, as Chris was saying. At the same time, something which was mentioned before, also by Jose Ignacio, is very important, that we managed to bring a different time scale in the mind of investors and of companies. Normally, companies expect return on investment on 2 or 3 years. Now, everybody understands that this is not the case for quantum computing. So something which we needed to keep doing is not only the quantum control, but also the quantum hype control, in the sense that the expectation management has to be very clear. And as we progress, we should not just be taken by expecting that next year, yet again, complete revolution. But, you know, this progress is going to accelerate, is going to be much broader, it is going to reach society. Maybe not a discontinuity now, such as this big result of quantum supremacy, but, you know, a broad, strong development across all the board.
Спасибо. Я вот этот же вопрос сейчас Кате адресую, но немножко...
Thank you very much. I will now ask Ekaterina in a slightly different aspect. I know that you have to convince high officials that quantum technology is important, that it will not be possible to live without them. What do you want, what would you like your colleagues to make in the world so that it will be easier for you to convince others? First of all, I fully agree with Chris and Tommaso that it's important for a quantum computer to do something useful. I would also add that this useful task should be also easily understood by people who are not experts in certain areas. It should be obvious on the common sense level, and it will be a real trigger, because if you have to explain what is this all about, what this task of optimizing the loading of 12 into container, it will not impress officials, because that's what we already do. We are already loading those containers and we are doing it well. But if they understand that it's possible to do something that has not been possible to do, and it's very obvious to see the value of a quantum computer, it will be a real breakthrough. I think we are speaking not about any industry, but rather B2C industry. It's like the question of creating not new remedies, but rather new vaccinations for new viruses, for example. Thank you. Yes, I get it. We keep making the task for the scientific world more and more difficult. Make something useful, now make something that everybody can understand. Yes, it is important. Daniel, maybe you can share some of your comments. What can we expect?
So, I mean, I agree with everything which has been said so far. I think there's not too much to add in this direction. Maybe I should say a little bit more viewpoint from basic science. I think the next breakthrough in quantum computing will be once we have a logical qubit. So there is no platform yet which has been able to demonstrate a logical qubit. A logical qubit consists of many physical qubits. The smallest one can have is 16 probably we need about 50 physical qubits to have a good logical qubit. That means a logical qubit which you can put in any desired coherent superposition and maintain that quantum state indefinitely. And I think once such a demonstration has been made on a real system, whatever platform this might now be, I think this will be a major breakthrough. Now, it will not translate immediately into a product, of course, you know, this is also clear, but I think within the science community, connected very closely to technology, I think this will be the next watershed. And I expect that this will happen within the next 5 years. And then we will see another push. As far as it goes then to real-life applications, I think one should not forget about the so-called quantum simulation. Quantum simulation does not, build on an all-purpose machine. It's a machine which can be designed to simulate physical processes directly, and the demand then on the control of the quantumness of the system is much less. And such quantum simulators, they could be extremely useful, for example, in the development of medication. So chemical processes which are studied in that field, they require an tremendous amount of calculational power, and also just by trial and error it's not possible really to make progress. But if you had a quantum simulator which would help you to simulate certain chemical processes and to understand faster how to build a better medication, or also treatment against viruses and so forth, that is one of the very important challenges. And this is not only hardware, this is also software, that people actually think about these problems and figure out how to use quantum mechanics to solve a problem of real life optimally. And since now the hope and the promise of quantum computing has spread out of physics in many other fields, there are now many very clever algorithms coming out which we have never thought of. I mean, Chris mentioned that, for example, in business, that's something we did not expect, and it's coming now. And I think this kind of triggering is self-sustaining and getting more and more ideas into the field to go towards such near-term quantum advantage or application, which I think we will see in the next 5 years for sure.
Да, спасибо.
Thank you so much. And I would like to get some comments from Jose. Mr. Jose, you mentioned that there is pressure from the government, and such events that we have mentioned here, they will make it easier to convince the UAE or any other governments that they cannot live without quantum technologies. Jose, the floor is yours.
This helps, definitely. Seeing progress all over the planet is a very helpful fact. But I agree with all the comments that the other panelists have made, that really agree with all of them. Therefore, let me add 3 small ideas, which are a little bit have not been mentioned. The first is that in the short term, we will see an enormous collaboration of classical quantum computing in supercomputing centers. And the example is Tommaso's effort in Jülich. It's obvious that supercomputing centers are the natural place to explore the ultimate edge of computing. And if it is a quantum device, they should be related to that. This is a non-trivial challenge, by the way, because whether you have the quantum computers in the same place as a classical computer is not obvious. And in this sense, Europe has this EuroHPC initiative, and this is also happening all over the planet in many other places. So the combination of supercomputing centers and quantum computers. The second idea I wanted to bring that I see happening is the challenge of classical technologies against quantum technologies. So there are, for instance, companies doing quantum-inspired algorithms, but they run on classical computers. It turns out that they are very clever algorithms, and you have to take into account that what quantum supremacy meant a few years ago, now it is completely changed, because the classical piece has improved a lot. Of course, there is an exponential gain at some point, but I may foresee an effort from classical optical computing coming into place and challenging, in particular, some of the applications that people claim that quantum computers may have. And this is very interesting, to have a good competitor on the classical side. And the third and last comment I want to say is about algorithms. Recently, there has been an enormous amount of people coming to produce papers. Now, whether the level of the algorithms we have has improved dramatically, I don't think so. I think that there have been many, many papers trying to translate ideas from machine learning to a quantum setting with no results that really promise that quantum computers are better in many, many of the papers. So this is related to the, to talent. How do we develop talent? So what I think that it will happen in the short term is that we will need an enormous effort to bring talent which is not very fluent with quantum physics. Yet, in order to have good algorithms, I think we need to have this advanced talent, let me say. It's like, think of the classical world with many people knowing to program, but really at the low level. If everything has to be based on libraries, which are universal, then the quantum computer will produce a small gain, I think. I think when you deal with a problem in detail, making a good algorithm is very, very difficult. So I think we will see much more efforts in developing high-level talent for algorithms.
Спасибо. Да, действительно, стоит сделать, но все-таки...
Yes, indeed, many things still need to be done, thank you. But to draw a bottom line, I heard this consensus. When will the tasks completed by the quantum computer will become useful? If we demonstrate that, the interest towards the industry will not just grow, I guess there will be another shift in the heads of the society. And of course, this is going to be very important. And it appears that, as our panelists are saying, this is not... well, we don't have that long to wait. It's out there somewhere. Something useful will be emerging, accumulating, and that will change the thinking of the society. They're saying that our time is up. But I think it's been a very interesting discussion. We discussed many issues, many of the things, of course, we haven't discussed, but this is the way it's supposed to be. We should, it's like you should leave the table while still being a little hungry. So thank you very much. Very interesting speakers once again. Thank you very much, and see you, I don't know when. When's the next expo? Maybe even before then. Thank you very much and goodbye.
Thank you.
Bye-bye. Thanks.
Bye-bye.